Welcome. Section 4.7 is on logarithms, and I would guess this is a very new concept for most of you, if not all of you. So, how cool is that? So, what is a logarithm? We'll get into that momentarily, but I want you to just take a moment and maybe do these two warm-up questions. I will talk through them, but take a couple minutes, pause the video, and work through those. It'll be a good checkpoint for you to see how you are with solving and finding the inverse. All right, with the first one, I just kind of went through the steps so you can check your work in solving. So I subtracted the 13 first to get 21. Then I divided both sides by 3 to get the 7. Remember, you can't distribute a 3 into the square root, or you can't combine the 9 and the 13 because one's in the square root and one is not. So you're kind of isolating the radical. Then once a radical is isolated, nothing else around it, now you can get rid of it. And to get rid of a square root, you're going to square both sides. So I squared the left, squared the right. 7 squared is 49. And the square cancels out the square root. And then you're down to just basic linear functioning. So subtract the 9 and divide both sides by 5, and you should get x equals 8. Always remember to check your answer. If you go back up, and I'll just verbally check it, if you plug 8 back in, 5 times 8 is 40, plus 9 is 49, square root of 49 is 7, times 3 is 21, plus 13, check, is 34. All right, and then finding the inverse, switch x and y, and then you can subtract 4 over to the other side. Then you can divide this 3 out, and just like the radical, you can't distribute a 3 through to a rational exponent quantity. So divide the 3 over. And then to get rid of a 2/3 power, remember you raise both sides to the reciprocal. You also cannot distribute a 2/3 power to a sum. So be really careful with that idea. So raising both sides to the 3/2 power, that will cancel out the 2/3 power. So you're just left with y plus 2. And then you can subtract the 2 over to the other side, and you are done. So again, you can't distribute a power through to a sum or difference quantity. So it's just this big quantity to the 3/2. Notice inverse notation as well. Don't forget about that. So if you hopefully did well with these, if not, come back and practice these again. You always have this video to check your answers. All right, on to logarithms. We will talk about what this means more, but I want you to, again, actually pause the video one more time and look at these 4 questions and see if you can find a connection between them. So take a moment. So maybe, or maybe not, but you noticed that the small number here on all of these logs, okay, it's called a base. If you swing around, 2 to the 3rd is 8. 3 to the 3rd is 27. 10 to the 4th is 10,000. 5 squared is 25. I'm not sure if you noticed all of those. I'll unveil them, but that is the pattern that I would hope you would notice. And of course, when it's in exponential form, it's real easy to see that that's a true statement. Like we do know that 2 cubed is 8. This right here, all of the black statements, those are called logarithms. And logarithms are just another way to write an exponential quantity. So if I know that 5 squared is 25, like we all know that, right? So then I can also write it in logarithmic form. So this log base 5 of 25 is how you would read it. That is really just the number 2. And it seems very awkward because there's like a word in there, letters, but it really is just a number. We use logarithms to solve exponential equations that we might have previously been stuck on. So we'll get there here in the lesson as well. So if you are comfortable with the pattern now, let's look at a few more here. So I'm going to evaluate these or find a missing piece if that's what's needed. Okay, so when you look at this first one, again, you read this as log base 2 of 16. And remember, that is just a number. So strange, I know. You'll get used to this, though. So what number is log base 2 of 16? Well, I'll come back to that. Same idea here, log base 2 of 32. What is that number? Or what if I work this one backwards? What base would make this log equal 2? Okay, so how are you going to figure all of these out? Well, now that you know logs and exponential functions are connected in this way, if you recall, remember you can do the big loop. 10 to the fourth equals 10,000. 5 squared equals 25. Why don't I just do that with these? And what I don't know over here, I'll just call x. So 2 to the x equals 16. 2 to the x equals 32. X, because I don't know that, x squared equals 100. So if I start by kind of writing those out, now I'm on, in some familiar territory would be my guess. 2 to the what is 16, that's 4. 2 to the fifth is 32. And 10 squared is 100. Okay, but again, that would be the thinking that you need to do. So now I filled in these logarithms with the answer. So log base 2 of 16 is really just the number 4 because of this thought process in exponential form. Log base 10 of 100 is really 2 because 10 squared is 100. Okay, so take a moment and look at the correlation between these. If obviously if the video is going too fast, that's the nice thing about the videos. You can pause and evaluate these. Okay, just one more set here. So again, if I'm trying to figure out all these question marks, I can put these logs into exponential thinking and figure out the answer. So if I loop this, 5 cubed equals what? What to the fourth is 81. 100 to the what power equals 10, right? So that's kind of your initial thought process as you go from log to exponential form. And then again, it should be pretty easy to figure out. I mean, 5 cubed, we know that's 125. 5 times 5 times 5. What times itself 4 times will be 81? That's 3. This one's a little more tricky. 100 to the what power is 10. Well, obviously, as x gets bigger, this is going to get bigger. So I know x is not an integer beyond 1. And you might see the connection between 100 and 10. If I square root 100, I will get 10. And do you remember what power is a square root power? It's 1/2. So 100 to the 1/2 is equal to 10. So now I can fill in all these blanks. I know that this blank is 125. I know this 3 to the fourth is 81. So that's the base of the log. And I know that this log equals 1/2 because the square root of 100 is 10. So hopefully you're kind of wrapping your head around the idea of logs, because now we'll take it a step further. So before we do that, again, I would at this point pause the video and see where you're at. Can you fill in all of these blanks? Can you solve these? Okay, let's see how you did. I'm just going to talk through them quickly. So 2 to the what is 32? 5. 2 to the what is 1/2. And again, this is tricky because you want it to equal a fraction. So 2 to the -1, remember negative exponents reciprocal it. So 2 to the -1 is going to be 1/2. 2 squared equals 4. 2 to the what equals 0. Hopefully you realize that's not possible. There's nothing I can raise to the base of 2 that's going to get me to 0. That can happen, right? So you absolutely cannot log 0. And while we're on it, you can't log negative numbers, right? Because 2 to the what is going to be negative. That's never going to happen. Okay, 2 cubed equals 8. 2 to the 1/2. Well, without my calculator, I don't know what that is. 2 to the 1/2, that's the square root of 2, which is like 1.4, which would be fine if you approximated that, by the way. Or I'm just going to write it as 2 to the 1/2. 2 to the what is 1/16. Again, tricky with the fraction. I know 2 to the 4th is 16. So 2 to the negative 4th, well, reciprocal to 1/16. And last but not least, 2 to the 0, anything to the 0 is 1. Ooh, all right, rocking and rolling on to the next ones. What if you have exponential situations? Okay, now solve these for x. That should be kind of the easy part. And then see if you can write them in log form. So again, pause the video and take a second and see if you can do all of these. Okay, so first one, 2 to the 5th, 2 times 2 times 2 times 2 times 2. We know that's 32. In log form, it would be 2 log base 2. And if you want a connection, the base of the exponent will always be the base of your log. Okay, so 2 and 2, if that helps. And then these kind of flip-flop positions. So log base 2 of 32 equals 5. And if you're more comfortable going from a log to an exponent, then just check it. Do your loop. 2 to the 5th equals 32. 2 to the 5th equals 32. So it's just backwards thinking. All right, 2 to the 0 is x. Anything to the 0 is 1. So we know x is 1. Log base 2, they're both bases of 2. Log base 2 of 1 equals 0. 3 squared, obviously 9. So log base 3 of 9 equals 2. 2 to the negative third, remember negative exponents, you reciprocal. So 2 times 2 times 2 is 8, but that's going to reciprocal to 1/8. So log base 2 of 1/8 equals negative 3. 0.5 squared, that's 1/2 squared, which is a fourth, or 0.25. And in log form, that would be log base 0.5 of 0.25 equals 2. And last one, 16 to the 1/2. Remember, a 1/2 power is a square root. So the square root of 16 is 4. So log base 16 of 4 equals 1/2. All right, now you have all the tools to go either form, exponential, logarithmic to exponential. Okay, we've practiced quite a few of them. Before we add on to this or take it one step further, if you see a log that doesn't have a base, it really does have a base. In fact, if you look at this one, I bet you can figure out what the base is. What squared, right? What squared equals 100? We know that's going to be 10. So if you don't have a base given, and this will happen to you, the base is 10 and it's called a common logarithm. It's common because it's so commonly used. Our Richter scale is measured by logs with bases of 10. So you actually won't see it because it's so common. So don't be alarmed if that happens. You just need to know that that's 10. All right, on your calculator then, I suppose you're dying to know how these work. I tried to account for all of the TI models that might be out there. If you have an Inspire or any other Casio, you might have to Google how to do this. It should not be anything too challenging, would be my guess. But if you have a regular newer model of a TI-84, if you're going to, in blue, by the way, here's what we're going to evaluate. So log base 2 of 32. Okay, if you're an 84 user, you go to your math key, and then you're going to up arrow 2 times, and you should see letter A says log base. I have a screenshot of it here. When you choose that, it's going to give you log with boxes that you can fill in. You can fill in the base, you can fill in what you want to log. So if you're going to log base 2 of 32, you literally just plug in the boxes. Press enter and you get 5. Not that you would need your calculator to evaluate that one, right? If you have an older 84 or a TI-83, you don't have the log base button. You can run an update on your calculator if you want to get that, but being we're not face-to-face learning right now, we can't really help you with that. So easy fix is you just take log of your big number, so log of 32, and you divide it by log of your base, which is log of 2. Okay, and I should probably show you all 84s your log button is right here next to 7. Okay, sorry. Okay, then so again, if you type that into your calculator, you should as well get 5. Lastly, 89s. I know a few of you have an 89. If you go to your catalog key circled in red, and then it's alphabetical, you can scroll down. If you don't have log base, you will definitely have the log button. If you have the log button, you just type in the parentheses, you type in 32 comma 2. So again, big number and then the base. It has to be in that order. And when you press enter, you should also get 5. While I'm on it, 89s, if you do diamond 7, some of you have a hidden log button. So if you remember that, that's great. It saves you from going to your catalog. So I will let you play around with that depending on your calculator model. All right, and then we are going to end with kind of the grand finale, like really why in the world are we going to use these? So I'm going to go back to the other day when we talked about your car being worth half the value of when you bought it. I don't have the details of the numbers, but if you wasn't that long ago. So your car was initially purchased for $14,000. It went down by 1/5 if you recall that problem. So this models the value of your car. Okay, when is the car going to be worth half? So I put in 7,000 for Y. And then algebraically, I divided the 14,000 over. And then we kind of got stuck here, right? And we're like, oh, I could guess and check, or I could graph the model and the 7,000 on my calculator and find the intersection. So we talked about some great strategies. Now you have another probably best strategy here is when you're stuck in exponential form, you can go to logarithmic form to solve for x. Okay, so take a second and look at this algebraically. What is that going to be in logarithmic form? Well, if your base is 0.8, the base of your log is going to be 0.8, right? So if I put that in log form, log 0.8 base of 1/2 equals x. And now I can type in logs in my calculator, right? So go to what I just showed you on your calculator, type that in, and you'll get 3.106, la la la. That's exactly what we got when we did the intersection feature on our calculator. Clearly these can get more complex algebraically, but right now this is as complex as it will get. So you can officially solve any exponential function. One more quick example, and actually why don't you try this one? So if you recall, we talked about putting money into the bank. So we put 3,000 into the bank with a 2.7% interest rate. We wanted to know when our deposit would double. Okay, so I'm going to put 6,000 in for Y. Divide both sides by 3,000 to get 2, that doubling feature, right? Here it is graphically, like where is the model going to equal the 6,000? We got the intersection. So after like 26 years, see what you get in log form. See if you can put this into logarithmic form. So again, base of the exponent's 1.027, so the base of my log is also 1.027. So log base 1.027 of 2. Type that into your calculator to solve for x, and you get the answer. So there you have it. That's ultimately, from an Algebra 2 standpoint, why we need logarithms, so that we can help solve our exponential equations. All right, so here's your homework assignment, also on the calendar, the Google Doc, if you need to reference that. And you have a wonderful day.